Hi, my name is Michael Thomas, and I was researching in the area of lead qualification and lead scoring. Let me explain. There is something called a capacity constraint problem, or the sales black hole, which is that it's much easier for teams to generate leads than for the sales team to follow them up. In other words, by the time the leads get to the sales team, 90% are eliminated, and only 1 to 6% are followed up and become customers. And so small differences in which leads are created, which leads are selected, create large differences in revenue. So in practice, firms manage this by a layering approach. They first of all apply predictive lead scoring, which generates a list of ranked leads, and then then the sales team applies lead qualification, which applies qualification frameworks such as BANT, MEDDIC, CHAMP, SPIN to choose which leads they're going to follow up. Whereas most research on the topic has incorporated scoring and qualification into a single-step prediction model. And this then creates a gap for my research. My research is going to look whether the layering approach actually improves the ability to predict the leads that are convert more than lead scoring alone. So my primary question is, when a sales team can follow up only K leads, does adding a qualification layer on top of an operationally defensible lead scoring model produce better outcomes than the scoring model alone? And there's some subsidiary questions. Does the qualification layer improve conversion rate? Is the conversion rate robust to the signal is applied? And is the improvement robust across different capacity assumptions? I will get into this later in this presentation. In my literature review, I noted 4 different streams of research, which I'm attempting to combine into a single model. The first is predictive scoring. This is where machine learning models have been ranking leads and produced a ranked list of leads, and has created a huge impact in how lead scoring is done in practice. Second is predict and optimize. This is from operations research, where operations research has clearly identified decision-making under constraints, and they have separated out the prediction problem from the optimization problem. The third is hard constraints. These are the ineligible leads which need to be removed from the leads before they can go into the machine learning model. And then the soft prioritization or the lead qualification approaches such as BANT, MEDDIC, CHAMP, which sales team apply in practice. To this, I applied 3 systems, and I'll get into these into more detail in the next pages. But the first system is essentially a baseline system, which takes the XEducation data set and simply applies a machine learning model to that. That model is used in System 1, System 2, and System 3 to be able to test whether System 2 and 3 produce independently better results using the same baseline. I'll explain this in the next few slides. The second system is a tier qualification system. This is going to emulate a qualification approach, which is going to find a pocket of leads which are high value, which is based on information that would conceivably be used in a post-scoring scenario. I will share more about how I do that. And the system 3 is where I take those same prioritization factors, but instead of prioritizing groups, I'm going to blend them into a new machine learning ranking. And in order to evaluate these systems, I'm going to use primarily precision K, which is the proportion of leads that will actually convert. And as I mentioned, the ML model in System 1 will be used consistently across all 3 portfolios. So first of all, let's see what signals are withheld from the machine learning model. Obviously, here I'm trying to emulate what would happen in a prediction layer and then a qualification layer. And the idea would be in practice that the information in the qualification layer would only become available, for instance, after the lead scoring would occur, for instance, through a communication with the customer, some sort of conversation with them where they would be qualified as a lead. And so the two columns which I've extracted out as being BANT-like or similar to a qualification layer would be the occupation. This may only be confirmed through a sales developer sales development representative interaction, where you might only find out what their occupation is later on. And then the last activity, which is SMS sent. And the reason I chose these, the working professionals and SMS sent, is that these, if I had to look at it as a business person, then these would have the pockets of leads that, based on information that would only occur post lead scoring, which have a higher conversion rate. If I knew that the working professionals have a 91% conversion rate, then I would prioritize that tier first. If I knew that SMS sent had a 59% conversion rate, then I would prioritize that tier second. And as I said, this has been withheld from the machine learning model because it is only information that is assumed to be obtained afterwards. And that's the basis of this dissertation. And both signals are withheld from the machine learning model. And these two signals, ST2 uses them for a tier allocation. So I choose first will pick leads from working professionals, then I'd pick leads from SMS send. But system 3 uses the information in a blended way, which I'll get to. So these signals illustrate the central idea of the dissertation. Qualification contributes value by incorporating information unavailable when the predictive scores are first generated. Then, after withholding that information, I created a baseline machine learning model, and I selected XGBoost because it's got a higher area under the curve of 84.8%. And yep, I'll use that in system 1, 2, and 3 in slightly different ways. So let's have a look at how system 1 and system 2 work. In system 1, I'm going to assume that the capacity I can follow up is 20% of the lead portfolio, which is 302 leads. And I'm going to take the top ranking leads by machine learning only, and I'm going to find out how many of those leads converted, and that is 265 converters. Next, what I'm going to do is I'm going to use a prioritization approach in system 2, which is I'm going to first of all take the priority 1 leads, which is working professionals that exceed the baseline of 39.8%. And there's only 92 leads in that priority group. Next, I'm going to take the SMS sent leads that are greater than the baseline of 39.8%, and there's 120 leads there. And the third tier, which I'm going to take then, is from the machine learning overflow. I'm going to then look at the leads that weren't taken out through working professionals SMS sent, go back to the original machine learning baseline and extract them. And in the same way, I'd also get 302 leads. And here I increase my number of converters by 5. So the tier membership determines allocation. Each tier is limited to a maximum of 40% of K, which is the number of leads which I follow up, in order to create some sort of, so that no one tier overrides everything else. And then the machine learning score determines ranking within each tier and prevents low scoring leads from being promoted. So even in this case, I'm incorporating the machine learning model within system 2 to firstly remove leads below the baseline and to rank the top leads, for instance, in SMS sent. And then obviously that the leads overflow would be based on the machine learning ranking. Let's have a look how system 3 does it. So we've looked at system 1 already, which takes the top 302 leads ranked by machine learning score only. In system 3, I apply a re-ranking approach, if you like. It just takes 90% of the machine learning score plus 10% of a qualification score. The qualification score is 0 if a lead is neither a working professional or a SMS sent. It's 0.5 if it's either a working professional SMS sent, or if it's both a working professional with SMS sent, will get a ranking of 1. And you can see here this only marginally improved the ranking, even though I took the prioritization groups that were used in system 2. It did not have the same effect. So the qualification only gives a small boost. But this is often too small to move leads across the top K selection boundary. So the main finding of my research is that the system 2 qualification outperforms system 1 and system 3, the blended approach. Systems 2's larger gain of 1.7% shows allocation matters more than score adjustment because the allocation approach, the tiering approach in System 2 managed to beat the blending approach in System 3. So let's have a look at some of the secondary metrics. These are all say the same thing, that System 2 is really the dominating system here. The wasted effort is just the opposite, as 1 minus the precision K. So you would expect it to be to go down when precision K increases. Recall is the amount of the total number of leads in the portfolio that the system was able to identify. So System 2 identified 44.9% of the total number of leads that converted in the portfolio. And the lift is just the improvement that precision K makes over the baseline of 39.8%. Yep, so System 2 definitely better. Then I applied some bootstrap confidence intervals. I selected 1,000 iterations from the data. So there might be some common, some of the same leads which were selected over and again, but this generated confidence intervals. And you can see they overlap. So in System 2, the 2.5% confidence interval of 85% overlapped with a 91% confidence interval of System 1, and the 93.1% confidence interval of System 2 was higher than the others. But basically, it was the bottom 2.5 which overlapped with System 1 and System 3. Which means that my results probably are just directionally consistent. We probably can't say that on a statistical confidence interval level that I've proven on a 95% confidence level that System 2 is better, but it is directionally consistent. Now let's have a look at some of the other sensitivity tests that I did. I first looked at the capacity constraint, which I'd assumed was 20%, that you could only follow up 20% of the leads in the portfolio. I then said, what if we could only follow up 10% of the leads, or we could follow up 30% of the leads? And you can see that S2, System 2 did the best under all of those scenarios, beating System 1 and System 3. And then what I did is I looked at the tier cap capacity sensitivity. So if you remember correctly, that each tier is limited to a maximum of 40% of K in System 2. And I was trying to understand what would happen if we changed that that cap. So for instance, if we could take 20% of priority 1 group, 20% of priority 2 group, which is SMS send, and then there'll be 60%, which will be taken from the broad machine learning rankings. That generated 88.7, which was still better than System 1 and System 3. And if I took 60%, it was 89.4%. What's interesting here is that when I took 100% of priority groups 1 and 2, the System 2 actually performed worse, which means that you're including more low ranking leads when we prioritize, when we basically take 100% of all those leads that are in those priority groups. We still need the machine learning ranking filter to be able to eliminate the low leads and be able to benefit from the high ML ranking scores. So let's have a look at another test that I did. Here I took System 3 and I said, and in our baseline, we said that the System 3 would be 90% machine learning score plus 10% of the qualification signal score. And I changed this. I said, what if we had 20% of the signal score? So if it was in the priority group 1 and 2, this would then have a 20% adjustment. If it was in priority group 1 or 2, then it would only be a 50% of that. And you can see here that it didn't really make a difference. The priority ranking score state, it was still worse than System 2 despite the tier allocation. So let me, I guess, share the mechanism that I learned about what lead qualification does, which is not in the other literature, at least on lead scoring. Basically, the machine learning model predicted information at lead creation, a rank of leads. And it enabled us to basically remove the cutoff leads below 39.8%, which was the baseline of conversion. When we did lead qualification, we would have got additional information through commercial information, through sales interactions, for instance, and we'd have selected these pockets of leads with high conversions, working professional 91%, SMS 59%, which far exceeded the baseline of 39.8%. And by combining these two models, we were able to get a higher precision K. So neither component works alone, and uncapped tier falls below the baseline. So qualification adds value by uncovering commercially important information was unavailable when the predictive model generated score. When that information identifies high conversion groups, such as in this case, working professionals and SMS sent, scarce sales capacity can be redirected towards better opportunities while preserving machine learning ranking within each group. So here's how this changed my thinking. Initially, I assumed that qualification would outperform scoring, and it only worked when the machine learning ranking was preserved. Secondly, I thought any use of qualification information should help, so the blended approach or the tiered approach. And it proved that system 3 only produced a small improvement when we blended, when we changed the ranking based on the prioritization of groups. And so it mattered whether that the signal was used in a tiered way, where we selected groups based on tiers. And the third thing I assumed at the start was that qualification should always override machine learning. And what I discovered is that because they're dipping into two basic sources of information, that qualification only helped when a genuinely new information appeared. So qualification should be viewed as a structured information acquisition rather than simply a downstream decision framework. So the conclusion I have from my research is that a qualification layer can improve lead selection beyond prediction scoring alone when it introduces information unavailable at the point of scoring. This improvement is directional based on my research because of the overlapping bootstrap confidence intervals. Both the signal and the mechanism matter because we need to have not only the prioritization groups, but we also need to use the correct tiered approach. And this research supports the industry practice of layering qualification policies on top of lead scoring systems. So the contribution of this research is not that qualification replaces machine learning. It shows that predictive scoring and qualification perform complementary roles. Machine learning predicts from existing information, and qualification systematically acquires commercially relevant information, and together they improve constraint lead selection. There's some limitations with this work. Firstly, I used a B2C dataset, and arguably it'd be better to have a B2B dataset where the BANT information is available. Secondly, the other limitation, as I mentioned, is that my result is directional only. We haven't been able to prove this within a confidence interval based on the data I have. And there's some minor limitations, which is that the signal separation, such as the SMS sent, has some sort of overlap with some of the other qualification, with other columns, which I guess could, in some sense, mimic real life. That none of the post-qualification information may be completely isolated statistically, and that there's no field level timestamps in the data set. In other words, I can't say from the data set when that information was obtained. I've identified a number of interesting areas for future work. So for instance, we could validate using real B2B CRM data with BANT. Secondly, we could investigate which qualification questions produce the highest value of new information, given that I'm now reframe this as the qualification as a information gathering exercise. That adaptive qualification that chooses the next question to maximize information gain. Extend to multi-objective evaluations. So, for instance, qualification may not just be for probability of conversion. You could be trying to maximize revenue, account value, or some sort of other strategic goal. The model how qualification information migrates into predictive models over time, which is what I guess the current research is assuming what happens. The test completes complete separation by excluding last notable activity and predict not only who will convert, but who remains open to influence. And this is based on some research, which is saying that you should only be spending sales resources on leads that are more likely to change their buying based on whether sales intervention is made, not focus on someone who's already decided to buy, but focus on those that will change their behavior as a result of having a sales intervention. That's it from me, and thank you. You can contact me on the email address.